Today we will be looking into this theorem and prove it using the geometric series. The theorem is that the limit of x to the power n minus a to the power n divided by x minus a as x tends to a is equal to n into a to the power n minus 1. So we can use this theorem when solving our limits. So here, for example, if we take limit of x cube minus 8 divided by x minus 2 as x tends to 2. Here we can write 8 as 2 to the power 3. So now we can see that this is in this form. So we can write n into a to the power n minus 1. That is 3 into 2 to the power 3 minus 1. So this gives our final answer 12. So now we are going to prove this using the geometric series. So here now let's take our theorem. We have the limit of x to the power n minus a to the power n divided by x minus a as x tends to a. So what we do first is we take x to the power n out of the numerator. So this gives us x to the power n into 1 minus a to the power n divided by x to the power n. And from the denominator we take x out. So this gives us x into 1 minus a over x. So now here we can see we have x to the power n divided by x to the power 1. So this means we will get x to the power n minus 1. So now what we do is we apply the limits separately to both of these. So the limit of x to the power n minus 1 as x tends to a will give us a to the power n minus 1. So now for the second limit, we use geometric series to get our answer. So have a look at this geometric series. Here we have a geometric series for n number of terms. So here the first term is b and the common ratio is r. So the first term will be b, the second term will be b into r, and the third term will be br into r, that is br squared. Similarly, we can get the other terms. This will go on for n number of terms. The nth term will be b into r to the power n minus 1. So if you remember your lower grade math, the sum of a geometric series, so of this geometric series, we can write as b into 1 minus r to the power n divided by 1 minus r. That is the first term into 1 minus the common ratio to the power of the number of terms divided by 1 minus the common ratio. So now let's substitute b equals 1 and r equals a over x. So what we get here is 1 plus a over x plus a squared over x squared plus a cube over x cube, so on until we get our nth term a over x to the power n minus 1. So our sum also will be 1 minus a over x to the power n divided by 1 minus a over x. So now if you look at the sum we got here, it is the same as the one in our limit here. A over x to the power n is a to the power n divided by x to the power n. So it is the same thing. So what we do is we substitute this whole geometric series for this into our limit. So that will give us a to the power n minus 1 into limit of 1 plus a over x plus a squared over x squared up to n number of terms as x tends to a. So now we use direct substitution for this. So that will give us 1 plus a over a plus a squared over a squared plus a cube over a cube until n number of terms. So you can see that all of this cancel off, giving us 1. 1 plus 1 plus 1 plus 1 for n number of terms. So that means we have n into 1. So finally we can get our answer n into a to the power n minus 1. So that's the proof of our theorem using the geometric series. In our next video, we will prove this theorem using algebraic division. Feel free to ask us any questions related to this topic in the comments below. Until we meet again, take care.